Hey, third grade, we are going to continue going over addition and subtraction models. So let's go ahead and get started. I'm going to read the problem without the numbers, and then I will go in and add the values and the numbers back into the problem, okay? Atonia had some colored rubber bands. She gave some of the rubber bands to her best friend. Now Atonia has some rubber bands left. Which equation can be used to find how many colored rubber bands she gave away? All right, let's try this again with our values. Atonia had 452 colored rubber bands. She gave some of the rubber bands to her best friend. Now Atonia has 125 rubber bands left. Which equation can be used to find how many colored rubber bands she gave away? Well, let's talk about this. What do we know about this problem? Are we starting with a total? Yes, we are starting with a total. 452 rubber bands. She gave some of them away. If you're giving some of them away, are we going to be using addition or subtraction? Good, we're going to be using subtraction. Do we know how many she gave away? No, we do not. So I'm going to put a box. And then what do we know next? She had 452. She gave some of them away. And then what happens? Good. She had 125 left. So if I drew my strip diagram for this, 452 total rubber bands. All right. I know that she has 125 rubber bands left. This represents what? Yes, this is the amount given away. All right, so I have a number sentence. I have an equation that I can use to help me solve this problem. 452 plus something equals 125. Well, first of all, I want you to look at the sum of this is less than this number right here. When you're adding, your sum is going to be greater. That cannot be your answer. 452 plus 125 equals something. Can the amount of rubber bands the answer that we find, can that amount be greater than 452? No, that cannot be greater. Why can that not be greater? Good. That cannot be more because we know that 452 is the total amount of rubber bands that she had. 125 minus something equals 452. Well, when I'm subtracting, the answer that I get cannot be more than what I am subtracting from. 452 minus 125 equals something. Now, while this does not look like this equation that we set up, if I wanted to find this missing number, I would take 452 minus the other number that I had, which is 125, and that would tell me how many she gave to her friend. So letter J is the correct answer. All right, let's look at the next one. The next one is dealing with strip diagrams. Jefferson Elementary has a total of 556 students in 3rd, 4th, and 5th grades. Okay, I'm going to read that again. Jefferson Elementary has a total of students in 3rd, 4th, and 5th grades. There are some students in 3rd grade, there are some students in the 4th grade, and the rest are in 5th grade. Which model can be used to find how many 5th grade students there are at Jefferson Elementary? Well, before I do this, I'm going to cover this up. And I'm using an old piece of paper. I'm going to create my own strip diagram. But before that I do that, I'm going to read this problem with the numbers in there. Jefferson Elementary has a total of 556 students in the 3rd, 4th, and 5th grades. There are 199 students in 3rd grade, 212 students in 4th grade, and the rest are in 5th grade. Which model can be used to find how many 5th grade students are at Jefferson Elementary? All right. I have a total of 556 students. Okay, I know that my total is 556 students, so the number of students in 5th grade is not going to be more than that. How many sections or parts are we going to have in the bottom of this strip diagram? Good, we're going to have 3. 1, 2, 3. This would represent 3rd grade, this would represent 4th grade, and this would represent 5th grade. 3rd grade has how many students? 199 students. 4th grade has how many? 212 students. And 5th grade has how many? We don't know. We don't know how many students are in 5th grade. So I'm going to put a question mark because that is what we are looking for. So let's use this strip diagram to help us solve our problem. All right. Well, first of all, I have a total, don't we? Okay, let's look at letter A. 199. They say that 199 is the total. Is that the total number of students that we have? No, that is not the total number of students we have. That should be, what number should be here? It should be 556. That answer is out. Letter B, 212 students, they say is the total. Is that my total number of students? No, that's not the total number of students. What is the total number of students? 556. Okay? So letter B is out. Letter C, it is missing the total. Do we know our total in this word problem? Yes, we do. Letter D, 556 students as the total. Then they have 212 in one box and 199 in the other box. It does not matter where you have these, okay? This strip diagram represents the strip diagram that we created. All they did was switch 212 and 199, which is not a big deal. Letter D is your correct answer. All right, let's look at this one. There were some people on the city bus. Some more people got on the bus. Now there are blank people on the bus. Which number line represents how many people got onto the bus? All right, I'm going to read this again, and I'm going to include my values. There were 18 people on the city bus. Some more got on the bus. Now there are 30 people on the bus. Which number line represents how many people got onto the bus? All right, so what are we starting with? We're starting with 18. 18 people were on the bus. And then what happened? Some more got on. So if more students or more people got on the bus, what operation is that? That is going to be addition. Do we know how many more got on? No, we do not. And then now we know that there are 30 people on the bus. So 18 plus something equals 30. All right. So my total amount is going to be what? 30. So let's look at this letter F. This lands on 15, 16, 17, 18. That tells me that only 18 people were on the bus. Is that true? No, that is not true. Letter G. This just goes all the way to 30. Does that demonstrate that we had an amount and then more got on and then we ended with 30? No, this word problem does not demonstrate that. This word problem just takes you, or this number line, I'm sorry, just takes you straight to 30 people being on the bus. We need to represent that 18 people were on the bus, and then a certain amount got on, and after those people got on, we were left with 30 people on the bus. Let's look at letter H. This first number line goes to right here. 15, 16, 17, 18. That represents that 18 people were on the bus. This next one lands on 30. This tells me that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This tells me that plus 12 more got on the bus and we were left with 30 people on the bus. Is this representing what this number sentence says? Yes, it does. Good job. All right, let's look at letter J. Letter J takes you straight to 30. And then what does letter J represent? This represents subtraction. So here they subtracted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They subtracted 12 and they landed on 18. This tells me that 18 people were left on the bus. Is that true? No, that is not true. 30 people were left on the bus. The correct answer is letter J. All right, don't forget to complete your interactive slides and your Education Galaxy assignment.